Hello students, welcome to the next module of your science chapter 12 electricity. As we have already discussed about electric circuits, electricity introduction, charge, electric current, the SI units used, the potential difference and the electric potential. I hope you have read your chapter till date. Next, we move on to our topic, that is Ohm's law. A very interesting topic, that is Ohm's law. This is the circuit diagram, that is for your chapter, this is figure 12.1. This is a setup for an electric circuit which we had discussed already in our previous lecture. We had discussed about the various components and how are they represented in an electric circuit. To recall, electric circuit is a closed continuous path that helps in the movement of electric current through a circuit. Right? So it's a closed continuous path, and that path is followed by various components. And these components are battery, a cell, voltmeter, ammeter, resistance, connecting wires, plug key, and so on. Okay, coming back to Ohm's law. This is an experimental setup of Ohm's law. Now what happens in Ohm's law, as you can see in this setup, this dotted part is the various cells which are connected in series, right? So if we just connect, we see this particular cell and not the entire battery. So what do we find? That when the potential difference across the particular circuit is 2 volt. Now what will potential difference do? It will let the electrons pass, and due to these flow of electrons, current will be created. So as a result, the current will flow through the circuit. Let us say that when the potential difference is 2 volts, the electric current is 6 amperes. Now, by adding another cell to this existing cell, so in other words, we form a battery here. That is a battery of 2 plus 2, which is 4 volts. So what will happen? There will be, since I have applied more potential difference, there will be more flow of electrons, and as a result, there will be increase in current. Now, when the potential difference across the circuit becomes 4 volt, there will be an increase in the current, and it will increase till 12 amperes. Further, if I add another cell of 2 volt, so the entire potential difference now becomes 2 plus 2 plus 2, which is 6 volt. So there will be proportional increase in the current. And this proportional increase in current will be, as we can say, this is when I have increased this potential difference to 6 volt, there is a proportional increase in current which becomes 18 amperes now. Likewise, if I add up another cell, and now the entire potential difference of the battery becomes 8 volt, the current through this circuit becomes 24. So what do we observe in this case? First and foremost, that when we increase the potential difference by 2 volts, here also we have increased by 2 volts, there is a proportional increase in current. That is, the current here increases by 6 amperes. Likewise, from 12 to 18, this again increases by 6 amperes. So with the proportional increase in the potential difference, there is a proportional increase in the electric current. So what will happen? When we take out the ratio of V and I, it will come out to be constant. How? See, if I put this, take this V as 2 and I as 6, so this ratio is 1 by 3. Likewise, if I take this as 4 and this is 12, this is again 1 by 3. If I take this as 6 and this as 18, this is again 1 by 3. 8 divided by 24, this is again 1 by 3. So we find in Ohm's law that when we increase the potential difference across the circuit proportionately, there's a proportional increase in the current such that the ratio of V and I remains constant. So what does Ohm's law state? Ohm's law states that the potential difference applied across a conductor is proportional to the rise in electric current through that conductor, provided the temperature conditions remain the same. So the definition of Ohm's law is very important and is represented by this particular relation. That is, in a given conductor, when we apply a potential difference towards the end of the conductor, that is proportional to the rise, increase, or probably decrease, whatever the value of V is, whether it's increasing or decreasing. So it leads to a proportional increase or decrease in the current. So we can conclude that V is proportional to I. And as we already know that once we replace this proportionality sign, it gets replaced with equal to and a constant value. And this constant value is R. And this is known as resistance of a conductor. Now, if I plot a graph between potential difference and current, so I see it's a kind of a straight line. Why is it a straight line? Because when we found out the ratio of V and I, it came out to be a constant value. Means with proportional increase in potential difference, the current is increasing proportionately. Therefore, the nature of the graph here is linear. Is that clear? I hope you are familiar with the definition of Ohm's law, which is very, very important. Coming back to this resistance. Now, what do you mean by resist? Resist is to control, to prohibit, right? So, resistance can be defined as the obstruction to the flow of electric current through a circuit. The unit of resistance is given by Ohm, because this entire setup of Ohm's law was given by the scientist George Simon Ohm. So the unit of resistance has been named after his name as Ohm. So I can define 1 ohm as 1 volt upon 1 ampere. That is, 1 ohm of resistance is defined as when 1 volt of potential difference creates 1 ampere of current through an electric circuit. It is known as 1 ohm resistance. Okay, please understand this particular definition of 1 ohm resistance. How would you define 1 ohm resistance? That when a potential difference of 1 volt is applied across the ends of the conductor, it creates a current of or generates an electric current equivalent to 1 ampere. So that is defined as 1 ohm resistance. Is this clear? Remember, the slope of this graph gives the value of resistance. So slope is equal to resistance in this case. And what do we mean by the slope? Slope means the angle at which this particular line is inclined with respect to the horizontal x-axis. Means this particular line, what kind of angle is it making with the x-axis is defined as a slope, right? So we usually, when we go on a hilly area, we say that it's very slopey. It's slopey means the angle it is making with a plain road is quite large, is quite big. So this is what we mean by the Ohm's law. Coming on to our next topic. Now, what does this resistance depend? Resistance usually depends upon the nature of a material. We will cover this in our next example. That is, you have a diagram, that is figure 12.2, where you have this particular setup. This also is a setup for an Ohm's law only. But the thing here is that this space XY has been left empty. What we will do is, in this experimental setup, we will replace this gap with a nichrome wire, then with a torch bulb, and then with a 10-watt bulb. So what do we see in all the three cases? When I put a nichrome wire here, the reading of the emitter, what does an emitter measure? It measures the electric current. So here the reading of the emitter would be different. Now when I replace this gap with a torch bulb, Now what will happen if I replace this with a torch bulb? The value of the resistance would again, the value of in the emitter will again change. This means the current, that is amount of current flowing through the circuit, will change. Again, if I replace it with a 10-watt bulb, this emitter value will be different again. So what do these conditions imply? These conditions imply that when will the current change? Now current will change depending upon the resistance of a conductor, right? So this means there is some property in these materials which changes the value of current. And what is this particular property? This is a characteristic property of the material of which these three are made. Since these three things, these three elements are made up of different material, therefore their characteristic property of resisting the flow of current through these materials would be different. And such a property, such a characteristic property is known as resistivity of a material. This is known as resistivity of a material. Please understand, resistivity is a characteristic property, whereas resistance is the property to resist the flow of current. Resistivity will be of a particular material. A particular material will have its resistivity. It will not change. It will remain constant, whereas that particular material can have a different resistance. Okay. Next, we talk about the factors affecting resistance. Now, what are these factors that affect the value of resistance? Remember, there are certain conditions. Now, since in this particular setup, this is a battery, right? The flow of current will be from the positive to the negative terminal. This is a plug key represented by K. This is an emitter and this is a conductor. What if the length of the conductor is doubled and area of cross section is the same? So the value of current will be different in this case. That is, I have changed the length of the conductor, but the area of cross section. Now for a conductor, what is the area of cross section? Let us say this is a cylindrical conductor. The area of cross section would be this particular circular area that I'm talking about. So this area of cross section, for example, in case of a wire, right? I can double its length, but its area of cross section, this will always remain the same. That means I can add another wire of same length on its top. So this will become double the length, but the area of cross section remains the same. Again, now the length of the conductor is doubled and area of cross section is same. So if we replace such a conductor here at this position, we note that the emitter reading is different. Likewise, in the next case, length of the conductor is halved and area remains same. Now what do we do? The area of cross section remains the same, but the length of the conductor is halved. It is cut from here and it is made half, right? So in that case also the emitter reading would be different. Next we have area of cross section of conductor is doubled and length is the same. Now what if we increase this area of cross section of the conductor, but the length of this piece remains the same? Then also the emitter reading will be different. Changing the material, nature of the material. If I replace this nichrome wire with a copper wire, obviously the nature of the material has changed. So there will be some change in the resistance, right? Again, changing the temperature conditions. Now, how does the temperature conditions affect the resistance? We will just see these one by one. Always remember that resistance, that is R, is always proportional to L upon A. This means resistance, value of resistance is proportional to length of the conductor and it is inversely proportional to its area of cross section. So what will happen in this case? That is, R is proportional to L upon A. So R is proportional to L. If I increase length, the resistance will also increase. And if I increase area, the resistance value will decrease. So that's an inverse proportion. Once I replace this proportionality sign, it gets replaced by equal to a constant value L upon A. So this is known as resistivity of a material. This rho, this sign is known as rho, RHO, and it is known as resistivity. And we have just discussed what is resistivity. Characteristic property of a material to resist the flow of current through itself. Is that clear? So what if, see, coming back to the very first condition, that is length of the conductor is doubled and area of cross section is the same. So the length is doubled, length becomes 2 times. Since length is proportional to resistance, so what will be the effect on resistance? Resistance will also double. Resistance will double in the first condition. In the second condition, length of the conductor is halved and area of cross section is the same. Again, what do? Length becomes half and area of cross section is the same. Since R is proportional to L, L has become half, so R will also become half of its initial value. Likewise, third, that is area of cross section is doubled and length is same. Area of cross section is doubled. So length is the same, area of cross section is doubled. It becomes 2A times. So what happens? Area of cross section increased to 2 times. Since R is inversely proportional, so R will become what? R will be halved again. It will become half. Likewise, changing the nature of the material. Next is nature. Nature, as I have told you, every material will have its own characteristic property known as resistivity. So it will depend from material to material, that how it will resist the flow of current through itself. So a copper and a nichrome wire has different resistivity. So they will likewise, copper has a lower resistivity, therefore it will allow current easily to pass through itself as compared to nichrome. The fifth is temperature. Now how does temperature affect? Please understand this very carefully. In hot seasons, in like hot summers, what happens? We usually observe that in summers the temperature is high and the length of wires, like we see the transmission wires on the poles, it increases. So as we know that resistance is directly proportional to length, so if length will increase, what will happen? The resistance will also increase. And with decrease in temperature, if the length decreases, resistance will also decrease. I hope you have understood resistivity. We will continue in the next tutorial.